Okay, it's recording now. So if you were going to try and calculate this confidence interval, basically now, remember the confidence interval, it's your estimate. So confidence intervals are calculated from samples, plus or minus the margin of error. So you need two things. You need your estimate. In this case, that's your p hat. For everyone, that turned out to be 48%. 48% of the sample was female for both of the two versions. Then you're going to have plus or minus. You need to know how many standard deviations. So that's what this Z star is for your level of confidence. So we'll calculate that times the standard deviation itself, which is now, you're going to use your estimate values in here instead of the null hypothesized value all over n. So this part, if I just did the version 1, would be 0.48 now instead of 0.42 times 0.52 divided by, what was it, 370 something? 378. So your standard deviation might be slightly different, but not much from what you had for the null curve. For the Z star, what you do, once again, I mean, I'm coming around and I'm seeing people who just seem completely confused. No notes. This should be in notes 5-6 times at this point. And here it is again. So if I want to know the Z star for 90% confidence, that means that I want 90% of the curve to be used, assuming centering the curve now at my estimate. So now I've moved my curve from the null value up, and I want 90% of that to be captured with this interval. If it were 95%, my Z star would be 2, because I need 2 standard deviations on either side. For 90%, I need less than that. So you look in your table, and 90% of the middle of the curve means that 5% is excluded at either tail. So here's 5%. So this is 0.05. From here to here, your entire interval is 90% of the curve. And up here, this is also 0.05. Add it all up, you have 100% of the curve. So the 5th percentile, if you look in your Z table, you look on the negative side, I guess. I'll write it over here. So Z, if you find the closest thing that you can to 0.05, somewhere in here, closest thing you can, and I don't know what these digits are. This would be negative 1.6 here, and either 4 or 5 up here. Something like that, 6.4, 6.5, something like that. Maybe 6.4 is probably better. Like that. That means that you need 1.64 standard deviations on either side of this average. So there's that, and there's that, and that'll be your entire confidence interval. So you put in 1.64 here, and you calculate it all out. You use a different sample size down here for version 2, whatever it was, 450 something. So when you calculate this out, I've got 4 minutes. I'm going to do 0.48 minus 1.64. Make sure this entire thing is under the square root, times 0.52 divided by 378. And I get the low end of the interval. And remember, please write this out with, I'll do this in blue, with interval notation. This is 0.44, rounding up. And then if I do the other side, if of the interval, if I put a plus there, I get 0.52. 0.48 should be in the middle of the interval. Your margin of error is about 4% on either side. So we're 90% confident that the proportion of women participating in that Olympics was between 44 and 52%. And then the other version, the only difference is instead of this 378, you would have the 400 whatever sample size. And your interval might be slightly more narrow. But the 42% is below this entire interval. So if you used the confidence interval to run the hypothesis test, you would get the same decision. All right. So, wait, I gotta show you this. Okay.